Okay, we are going to go over the review for our test on Friday, and question number 1 can be found on page 41 in your notebook. Page 41 is talking about additive and multiplicative relationships. So when it's asking us about the relationship here, that's what it's asking. Is it additive or is it multiplicative? And so right here, I see a plus sign. So I'm going to say that this relationship is additive. It's as simple as that, right? If it's adding, it's additive. And so I could say something like, because I see a plus sign. Okay, and then on the bottom one, we see y equals 6x. And remember, when the 6 is right next to the x, that means multiplication. So we would say that this relationship is multiplicative. And I would say something about because x is being multiplied by 6. On the last one, I could have said something about x is being added to 12 or something like that. Any way that makes me know that you know that one is adding and one is multiplying. Okay, so hopefully we don't make that more complicated than it is because it really should be pretty easy. Okay, this next one says write the ordered pair for each of the points below. So this can be found on page 40, coordinate graphing with rational numbers. This is rational because we see that there's something in between the whole numbers. So like, sorry, technical difficulties. In between the 1 and the 2 there would be 1.5 or 1.5. And in between the 2 and 3 would be 2.5 or 2.5. And in between 0 and 1 would just be half or 0.5. So that's what makes this rational. Point A, we go over to 2. So that's going to be our x value. Remember, you always go left or right first. And then we go up and notice it's right here in between the 1 and the 2. So I could call that 1.5 or 1.5, same thing. Point B also goes over to 2 on the x-axis, but it goes down this time. And because it's going down, we know that's going to be a negative y value. It's in between the -1 and -2. So that would be negative 1.5 or negative 1.5. Point C doesn't quite go over to the 2. It's right here in between the 1 and the 2. So that is going to be a 1.5. It's positive because it went to the right. If it had gone to the left into the negatives, it'd be negative. But it does go down. So we know that our y is, again, a negative value. It's going down past the -2. It doesn't show us -3 on the y-axis, but I went ahead and just added it because we know if it's in between -2 and -3, that's going to be -2.5 or -2.5. It's really important to remember that 1/2 equals 0.5. So if I say 2.5, that would work. Or if I say 2.5, those are the exact same thing. I'm just writing the 0.5s here for ease, but it doesn't really matter. Okay, D, we go over to -2 this time. So we're starting with a negative x, and then we're going down in between the -1 and the -2. So that's going to be -1.5 or -1.5. And then point E goes over to the left again, so it is also negative, but this time it's between -2 and -3, so -2.5. Then it goes up to this point right here in between the 1 and the 2, which is 1.5 or 1.5. Okay, our next problem. This is found on page 39. This is comparing and ordering rational numbers. So this problem is asking us to put them in order least to greatest. We want to make sure we're putting them in the right order. And I always tell you to make these look like money. So we just talked about the fact that 1/2 is the same thing as 0.5. If I add a 0 to the end of that, it's like 50 cents. Remember, half of a dollar is 50 cents. If you absolutely can't remember, I really want you to have that one memorized. But if you absolutely can't remember, you can always do top in, bottom out. 1 goes in, 2 stays outside. We divide, and that gives you that 0.5. For Sue's number, all we have to do is add a 0 and we're talking about $1.40. And again, if you look at this, this is not about money, right? It's about time, but it doesn't matter what it's about. If we think of it as money, our brains like money, so that makes it easier for us. Okay, this one is -1 1/4. Remember, a fourth of a dollar is 25 cents. 4 quarters makes a dollar. Again, if you absolutely can't remember that, I want you to have it memorized, but have a backup plan. If for some reason you're having a brain fart, you can't remember it, you can always do top in, bottom out. So we get that 0.25. Mike's number, again, we just have to add a 0, so that's like -$2. And then Tom's already looks like money. It looks like $1.95. If we're talking about least to greatest, we have to be starting with our negative numbers and think about what would be furthest to the left. Or again, with money, what would make you the most broke? So the most broke would be Mike here. If you owe somebody $2, that's the worst case scenario. That's also the one that's going to be furthest left on a number line. Then the only other one that's negative is Anna. That would be also owing somebody money, but only owing $1.25, which is a little bit better. Now, if we cross over into the positives, the smallest positive amount over here would be John at 50 cents, and then Sue with $1.40. And the person with the most money, again, if we're thinking of it as money, would be Tom. So that is the order from least to greatest. The next problem is also found on page 39. It's the same sort of problem, but we're dealing with a number line this time. So I told you to think about the number line last time. This time they actually gave us one. And again, we can think of this all as money. Pretend this is $24 and this is $25. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 little sections. So this would be like $24.10. And I'm not going to keep writing the $24, but 20 cents, 30 cents, 40 cents, 50 cents right there in the middle, 60 cents, 70, 80, 90, and then we get to the $25. We want to know which one is closest to 25, but we also need to put them on the number line where they go. So again, we want them to look like money. So that right there, I could put a 0 and it's $24.20. I'm going to come back to 24 4/5. This one, the $24.08 already looks like money. We keep talking about half. Again, half is one of those that I just want you to have memorized. So that would be $24.50. Half of a dollar is 50 cents. And then 4/5. We could come over here and do top in, bottom out. That will work. That's going to give us 0.8. Or remember, your fifths are like your fingers. 0.2, 0.4, 0.6, and 0.8. So 0.2 is 1/5, and then 2/5, 3/5, and 4/5 is 0.8. And then so 24.8, if I add a 0 on the end, that would be $24.80. Okay, so $24.20 is right there. $24.80 was that one right there. So that's going to go there. $24.08. That would be a little bit less than $24.10. So that one is going to go down there. And then $24.50 is going to be right there in the middle. So that's going to go right there. It asked which one was closest to 25. So this dot right there is the closest to 25. And so the answer was 24 4/5 was the closest to 25. Okay, this next one, you can find this, it's mostly on page 43. That's where we did our equations, but we did also talk about equations, graphs, and tables on page 41. So I went ahead and put that there. We have to do 2 different equations here, one for the graph and one for the table. I'm going to start with the table. Remember, we're trying to figure out what is happening to X to get Y. There's nothing that I can multiply 0 by to give me 6 because 0 times anything is 0. So we know we have to be adding here. It can't be subtracting or dividing because it's getting bigger. So we're adding. 0 plus 6 is 6. 1 plus 6 is 7. 2 plus 6 is 8. So remember that our equations always start with y equals. and then we have an x and whatever's happening to x. And so here we were adding 6 to x, so it's just y equals x plus 6. For this graph, it's hard to go straight from a graph to an equation. So I would always go off to the side and turn it into a table first. Look at your dots. So when I look at this first dot here, it's going over to 1 and it's going up to 4. So 1 comma 4. The next dot is going over to 2 and it's going up to 8. So 2 comma 8. And so when you do that, it makes it a lot easier to figure out whether you're multiplying by something or whether you're adding something or what are you doing there. And I can see that we're doing 1 times 4 to get 4 and 2 times 4 to get 8. So this is being multiplied by 4. So y equals 4x, which means 4 times x. Really hard again to get that straight from the graph. So really try to make that into a table. Okay, this next one again is from page 39 where we're putting things in order. This one's about temperature, but again, it really doesn't matter what it's about. I always would try to think of it as money. Our brains like money much more than temperature or time or anything else. When this says warmest to coldest, that's going to be greatest to least. And again, I'm going to try to make these look like money. So $3.40, negative 40 cents, negative 20 cents. This is 4 wholes, so that's going to be $4. And then negative $2.50. So our greatest numbers are going to be our positive numbers. And so the $4 would be the biggest one, so that would come first. The only other positive one has to come next, so $3.40. Once you cross over into the negatives, again, remember it's opposite land. So even though something might look bigger, if it's negative, it's actually smaller. So the one that looks the smallest is negative 20 cents. That's actually the biggest of the negative numbers. And then we would keep going left on your number line. You'd get to negative 40 cents. And then negative $2.50 would be the furthest to the left. So that is going to be our smallest number. And again, this problem has nothing to do with money, but my brain likes money. So that's how I'm going to put that in order. Our next problem is asking about the independent quantities, and you can find independent and dependent on page 42 in your notebook. This has some dots here. So you see these dots that are graphed, but when they're talking about independent and dependent quantities, we do not care about those dots. Remember that I taught you to draw something on the graph. So if I take my y-axis over here, I can make a capital D for dependent. And then on the x-axis, I can use the x-axis to make a capital I for independent. Now, we were talking about the independent, so that means we're going to be talking about our x-axis. And quantities just means numbers. So if this were the test, I would choose these numbers here as my independent quantities. If they had asked for dependent, I would want the ones along the y-axis. Last but not least, we've got a question where they've given us the equation y equals x plus 9.4, and they want to know they've given us the x values. They want us to complete all the y values. On page 43, we went the opposite direction. They gave us the table and we came up with the equation, but I like how this problem goes the opposite direction. So basically, you just have to plug these x values into the equation. So if x equals 1, I can just put a 1 right there, 1 plus 9.4. Remember, 1 is the same as 1.0. So if I add that to 9.4, I'm going to get 10.4. And honestly, we really shouldn't need any work for this, because if I know what 1 plus 9 is, then I should know what 1 plus 9.4 is. 1 plus 9 is 10, so 1 plus 9.4 is just going to be 10.4. 2 plus 9 is 11, so that's going to be 11.4. 3 plus 9 is 12, so that's going to be 12.4. And 4 plus 9 is 13, so that's just going to give us 13.4. And again, all we're doing here is we're saying here that all these x values have to be added to 9.4. So we're just doing 1 plus 9.4, 2 plus 9.4, 3 plus 9.4, and 4 plus 9.4. Okay, I hope you do great on the test, and rewatch the video if you need to, watch any of my other videos if you need to, and just do your best.